Welcome to episode 8, which is again about particle systems. And today I would like to show you a few more options, a few more possibilities what you can do with particle systems. Let's just get started. So I'm going to start a simple particle systems by creating create geometry switch to particle systems, and I'm going to create the pf source. And with the keyboard shortcut 6, or you can also type here in particle view, I'm opening the particle view. So the first thing that I would like to start with is the particles are not only being created on the emitter object. The emitter object, when you select your emitter object and go to modify, you can also choose something other than a rectangle, a box, a circle, and so on. But if you would like to start, if you'd like to create your particles on any object, for example, here is let's create any object, a standard object, a torus, here right next to. So here's a little torus. I don't want to create my particle on the emitter, but on the torus. This is how it works. So you select your particle system, and where is the place where they are born? So here is the birth event. Let me change that quickly to go from 0 to, let's start a little bit longer, from 60. And where are they born? That is defined on position icon, because it is on the volume everywhere on the surface of the emitter. So instead of having a position icon, you can override it, but what I would like to do is, for demonstration purposes, I just turn it off so it doesn't know where to create our icons, our particles. That's why instead of position icon, we're going to place the position object. So position object, and in position object we can define an object where the particles are born. So position object is the emitter list, and I'm going to add by list. So sorry, that was over here, and here's the torus. You can also go for add and just click on the torus, and now define where are the particles born in the surface, in the vertices, and so on. So here they are born all over the surface of our torus. Let me maximize it a little bit. So here it is, and here they are, particles born on the surface. Of course, it doesn't know which direction to go, because the speed in the next one is defined by along the icon arrow, and only the emitter has a certain icon arrow. So you just have to give it a different speed. For example, a random 3D, then they will be born anywhere. Let me change the color of the particles to something a little bit lighter, or even change the display to geometry. So then you can see the particles are born on the surface, and then they go in random 3D directions. Okay, so now they are born on the emitter. Also, here is the position object. You can also use the lock on emitter. That means when the particles are born, they are born and then they just stick to the surface of the emitter. I'll show you an example later on where that comes in quite handy. Okay, so that is how to create particles on any object. The next thing is how to create particles of any shape, so that you're not limited to whatever whatever shape gives you, the 2D and 3D shapes. So you want, instead of shape, you want to define your own shape. Your own shape, in my case, let's just go for a teapot. So you need your geometry as a piece of geometry. So here's my simple teapot, and I just place it over here. It could be any geometry, and now in my particle system, where I usually define the shape or pick a shape out of the list, instead of shape, I'm going to use shape instance. Here it is. I'm going to use shape instance, and in shape instance, I can define which is the geometry of the particle. So I click on none and click on the teapot. And from now on, it will create teapots as geometry. Of course, in a random rotation and so on. Okay? So that is how you choose your own particles. So if you have something special, like you want to shoot little rockets or something else, this is the best way to do. Here's also, when you are rendering with Arnold render engine, then if you want to use some special Arnold objects, for example, Arnold lights and so on, there's also an Arnold Shape instance. So if you use the Arnold Shape instead of the Shape instance, let's quickly do this. So I'm going to turn the Shape instance off. I use Arnold Shape. And then on Arnold Shape, of course, I can again pick the teapot. But with the Arnold Shape, you can also use some kind of other objects. For example, if you want to shoot out little lights. I've never tried that, but that might be nice, because in Arnold you see the lights and you can also see the effect of the light. Then this would be the way to go. So usually you can go with shape instance, but when you use Arnold, some Arnold special shapes, and it says when you hold your mouse here, it says what it is. It is of course 3ds Max objects, it's procedurals, volumes, and so on, and Arnold lights. Good. So that is the shape instance. So let me turn that away. The next thing is, yes, the lock on emitter thing. So when does it make sense to lock an object on the emitter? And what I have prepared is a little file. Let me quickly open that. Don't save. Yes, it's an old file. And it's in inches, I didn't know that. Okay, so here, no, I don't want to change it. So here it is, a very simple scene. What it does, basically, there is a little rock that has a weird shape, and all I did is I just animated the rock to roll down the surface. Why? Because I wanted to show you how dust could be created, dust while rolling down. So actually the dust usually will be emitted at the point where the stone or the rock is rolling on the surface. So wherever these two surfaces touch, this is where I want to create my dust, and that is a good example for how to use stick on emitter. So basically what all you need to do is you need to create particles that stick to the rock. So how did we do this? Let's create a let's do it the way I would not usually do it. Let's start, press 6 to open the particle flow, the particle view. Let's create a standard flow that creates a particle system somewhere. Here it is. So, and now fix the event. Here's the birth. I would like the birth event, the birth happening from minus, let's be on the safe side, from -2 to -1. So all the particles are born before my animation even starts. I would like to have a huge amount of particles, so let's go for 500 particles, all born within one frame. So as soon as I go here, see they all move right away. And the next thing is position. I don't want them to be born on a position icon. I want them to be born on an object. So I use the position object over the position icon, and the emitting object, I use my rock. And I would like to have my particles lock on the emitter. So they are born and stick to the emitter. So you can see they are all sticking onto the rock, sorry. Okay, so they are on the rock, on the surface. You can do a little offset if you want. If it's not perfectly rolling, you can make it a little bit outside of the surface for, yeah, we'll see it right away. Okay, so here it is. They don't have speed at all. they don't have, they can have, yeah, doesn't need it, but random rotation. The shape is, they don't need a shape actually here. Let's delete it. And the display is okay to have those little ticks. Okay? So they are all over my rock. Good. The next thing is, now how do I want to continue? I would like to find out whenever one of those particles is colliding with my plane. So that would be a collision, but not a collision with a regular object, but with a, so where are they? Here are the helpers and the space warps and the forces and the deflectors. So if you have a regular deflector, it is always a rectangle. So it's always a rectangle, and you can only measure it how it reflects with the rectangle. If you use a UDeflector, in the UDeflector, you can use your own, it's an object-based deflector, so not only a plane, but you can use whatever object you want. In this case, my plane, for example. So I use the UDeflector. It's the same symbol, it's only a symbol, and in the symbol, go to modify, you can pick your object, and I'm going to pick my plane. So if I now include my UDeflector into a collision test, it will test the collision with the object, with the plane. So let's do this. Here is my my event, and in this event I would like to check for collision. Collision with what? With a deflector, of course, and let's do with this deflector, the UDeflector. Okay, what is it doing? If it collides, it does nothing. It just continues. So if it collides, it just continues going on. But what I'm going to do is I'm going to go into a new event, and in the new event, when it's rolling down, every time it touches, every particle when it touches will create a new one. That means in the new event I will create a new particle. And the new particle will be created, so let's see, where are we? Here is the collision, and once it goes into the collision, it will, okay, maybe I should have done with a spawn. This is the next thing I would like to show you, is the collision spawn. Here's a collision spawn, and the collision spawn now is not only creating a collision, but it's also multiplying itself. Let's do it with a collision spawn. Collision spawn, here's the deflector. The deflector is the same UDeflector here, and it will not only spawn on first collision, because my stone is rolling and it's probably every particle is touching the ground more than once. So not only the first collision, I want to spawn on every collision. Let's get that higher until 10. And then depends on how many offspring. Let's go for 5 offspring. So it's creating 5 different particles. So, and those 5 different particles now, they will go into a new event. So every time it rolls, it creates 5 particles, and those 5 particles will now go into a new event. Okay, the display comes automatically. Let's go for a shape. And the new shape is a cube on collision spawn. Speed offspring, parent continue, offspring continue. Let's try this. Okay, it works. So let's try this. Yes, okay, so there it is. See, it once it rolls down, every particle that touches the plane will create 5 new, but the speed of the particles will stop, because I would like to give the particles a new speed once they go into their new event here. And for example, let's say we're gonna use for example, wind. So we use a force here. As soon as they stop, and then they go into the new event, and then they get a new force. And the force, for example, will be a wind. Let's get a wind from the left, like this. Create forces, wind, here it is. So like this, and the wind blows the other direction. So blows like this. And the particle, let's see how strong it is. I guess 1, yes, it's 1. And now the particles will get the force, and the force will be the wind. Here's the wind, very slow, 100 maybe, still too much. Yeah, still way too much. So let's take the whole wind and make its strength 0.1, 0.01. I want to slowly blow it away like wind. Like this, and also the wind will get some turbulences, and so like this. See, and now it blows it away. That's good. So the collision spawn, let's go for more offspring. We're creating 10 offspring, and the rest is good. So here it is. Right now it's just ticks. Of course we can see the shape, but you can see how it works. So we are rolling down, and whatever it touches, it will slowly blow away the dust. Also on the bottom, the dust will blow. Okay, so that was a quick example about how the lock-on emitter makes sense when you want to place it on there. We also talked about the deflector that not only deflects a plane, but any geometry that you add. This is the UDeflector. It's called UDeflector. The next thing is, let's quickly render it. I know it will not, it will just look, it will be boxes. Are there any boxes? The shape? Okay, so here is, they don't have any shape. Shape. It is a cube. Yes. Let's go for a sphere. And will be displayed. Something's weird. Let me quickly check. Oh, there's no. I've never seen that. There is no render engine defined. I didn't know that you can choose none. Usually it's always one out of the list. Let's go for a simple scanline renderer. So here it is. Right now the default is a sphere. By the way, how can you place a material onto particles? There's also different ways you should check out in the dialog box for the particles, that there is different ways that for dynamic materials, animated materials, and the simple way is a static material. So I'm going to place a static material there, but let's first open the material editor. is. The first time that I open my material editor, it takes so long because it loads a couple of material libraries, and that's why it takes so long. Simple material, we are in scanline render, so let's just go for a very simple standard material. Just to see it a little bit better, the standard material, I'm not going to use a color, but I'm going to use a map, and let's just do a simple checker map that I place as a diffuse color. The checker map, let's maybe tile it 2 by 2. So how do we place the material onto the particles? With the particle, in the particle event, placing the material static, and here is the assigned material. So you have the material editor and you just drag and drop it. No, that doesn't work, strangely. Let's one more time. Oh, it does. As an instance, okay, I dropped it as an instance, or you could just click on it and then grow it. So that's the material that is placed onto my object. So let's see if it shows up. Why is it not showing? Because my render here, render shows the geometry, display here, need to show the geometry as well. Okay, it shows the geometry, and let's hit render, and I'm missing UV coordinates, so that's why the material is not properly assigned. Let's check material static. Here's my assign material. No, sorry, not the material ID is important, but the texture coordinates. Let's see if the display geometry, the shape will here. I don't know why this should be turned on. Mapping coordinates are usually turned on, and then we have it's planar mapping. If you want your own, then we have to apply it ourselves. Okay, so that's it. We got the material placed on it, and when we render, the material will show up on those icons. The next thing that I would like to show you, and that is a lot of fun, that is let's keep that for a second, and let's create a new particle system pf source here. Let's go to our it's getting a little crowded in here. So here's my new, and I'm going to do something really simple. I just remove the speed, so it's not moving along the icon. It's still born on the icon, but it's not moving. It has random speed, it doesn't matter. And what I'm applying is a random walk. So the random walk now, my particles are born, but they just do a random walk. So here it is. My screen is getting too small. So they are emitted, and then they just randomly move around all directions, just like fly around a, I don't know, piece of something. So here it is, 250 frames long, and then they're moving around. The random walk basically has a sphere. It creates a sphere, and the sphere has a certain diameter. So the larger the diameter is, so the larger the area in which they walk around, in which they fly around. So if you make it larger, then they will go further away, and so on. So that's it. Now I have, how many particles do I have? Let's see. I have, let's make them all born at the same time. So from 0 to 0, all particles are born. They're all born at once, and then they fly around. And what I would like to show you is one thing. Those particles, they all have very strange paths that they do while they travel for the 200 frames. And there is a script that basically goes frame by frame by frame and creates a spline that shows the path of each and every particle. So in this case, it wouldn't make much sense because they're all crowded together. But in this case, they are like all over the space. And that's why we're going to run the script here with this particle system. So I'm going to select the particle system, and the script that I'm going to start is called pfSpliner. And I just found it. It's still available here. It's still available. I don't know actually if you can download it here, but it's from these guys there, pfSpliner. And the way it is, it works, it is an MS file, so it's a simple text file that is there. Sometimes the scripts are for copy-paste. So when you have a script for copy-paste, then you could go here and create a new script. Then you end up with a text window. Then you paste it in there, and then you place it in there, and then you let's see, where is it? You evaluate it. So as the shortcut, Control E. So you evaluate the script. If you already have the script as a file somewhere, you only need to go for script and run script, and then you find it. Here it is. And then it will not ask you, it will just run the script, and for 250. Oh, it will only run for 100 frames. For some of the settings, but you get an idea. So here it is. Let me quickly select the first spline, and then get them all together. Where is attach multiple? So here is the 100 frames. 100 frames for 100 splines, and here they are. And if I make it, give it a certain thickness, let's say 0.2, there it is. Now you have a geometry of splines where all the particles go. Here the particles at the end. If you don't want to see the particles, you just try to select it. So there it is, and hide, and now you only have the splines left. Okay, so the settings for 100 frames, I'm sure if you open the script and not run it, scripting, open script, usually it pops up with a window, but in this case you probably just end of animation. So, oh, it's German. So here you can say how long the script is. So how many frames, and here is also 100. This is the end of the frame. Sorry. Usually every second frame will only be calculated, and that's it. So here's the script that creates that. The one that I've shown on the website, the pfSpliner, looks like it's a little different because it got the window here. Good. So that was something a little bit more about the particle systems. As I mentioned, those are only the particle systems, the traditional particle systems. I think in 2014, the M particles just came, M particles, including some physics in it. So you can do all kinds of physics, collisions, soft bodies, rigid bodies, and so on. So you should check that out. There's tons of tutorials out there. It works slightly different, but it has all the events or similar events as we also did here in the first basic introduction. So I hope this gave you an idea what is possible with particle systems, what you would like to try to do. Check out all the tutorials that are out there now. If you want to look for a very specific operator, you can always find tutorials that explain you what to do, or also check out the help file. What's the difference between a material dynamic and a material static? You got yourself started now, and you'll find all the information out there. Good. I hope you liked it. Thanks for watching, and I'll see you in the next one.